Okay, we are live. So hi guys, hello. I hope everything works. But please let us know in the chat if you can see us, and of course if you can hear us. That's the most important thing. So, okay, we have 20 people live. That's great. Okay. Okay. Oh, now I have a confirmation, so that's cool. Okay, guys, so hi, I'm really happy that we are here all together today during the next edition of Functional World. Unfortunately, the last one in this year, but of course, we will meet in the next one. So if you would like to become a speaker in the next year, of course, you can write to me via LinkedIn or email. All our contact details will be provided in the chat. So no worries about that. And well, maybe I will introduce myself. I'm Matylda, and I'm responsible for employer branding at Scala. And also, my teammate Alex is here with us today, and she has a special message for you to, or maybe, I don't know, invitation more. So would you like to share it now, Alex?
Of course. Hi, everybody. I would like to invite you all to Functional Scala this year in London or offline as well. Online, sorry. We are going to have a booth at Scala, and we are going to also have 3 of our employees. They're going to be speakers as well. So if you want to grab a coffee or have a chat at our booth, you're very welcome. And of course, we're going to have some quizzes and contests. So there's going to be also, we're going to have amazing t-shirts. So guys, please come and see you there. Thanks.
Thank you, Alex. Perfect. And yeah, of course, you will have all contact details to Alex as well in the chat. So you can reach her out during the Functional Scala conference. And now it's time to introduce the most important person today, Enrique. But I hope you know him already from our social media or maybe from the last Scala team, which is also our meetup aimed at Spanish-speaking community. So I will say that he's a passionate software developer with extensive experience developing high-quality software for various companies. He enjoys researching different technologies and architectures, finding the right tool for the job, and using it in practice. He is also currently focused on blockchain technologies and ES-CQRS architectures, and you will find him learning music, tasting beer, or running on a beach in his free time. So that's Enrique. And Enrique, please let me know if you are ready, so we can start.
Yeah. Yes.
Okay, Enrique. So the stage is yours. Good luck. But now you are very experienced, so everything will be great. And yeah, thank you, guys. That's all from my side.
Thank you. And Enrique, as I was already presented. And today I'm going to talk about high quality code in Scala. Starting with I wanted to start with agreeing on what we mean by high quality code, so we can set some base and start talking from there. And given that the definition might be hard to get, or maybe there are as many definitions of high quality code as developers there are out there, I found that it would be easier to, instead of that, finding what are the traits that high quality code exhibits. And I think we can all agree that high quality code exhibits readability, extensibility, and maintainability, testing or verification. It has, well, good documentation, it's portable, it's efficient, and it's secure. The reason that there are 3 underlined traits is because those are our focus today. It will take a lot of time to speak about all of them. And yeah, so let's dive a little bit deeper into each of those three. What I mean by readability, I mean, well, format consistency, that is indentation, column sizes, using bracer, in which we write the, for example, class members, anything like that. Style consistency or coherence it's also to formats. It's we can say syntactic, but I like to separate it because I like to call style things that are more related to differences that can potentially affect the execution of the code. And by that, I mean, for example, if we or object-oriented approach, pattern matching, or we use, let's say, with an optional value, we use map and get or else instead of pattern matching, or fold, or different methods, different ways of doing the same. Naming coherence, it's pretty self-explanatory, but I think it's very important. It's important to this is another hard one to define, but basically having cohesive modules with clear responsibilities and scope. As a rule of thinking of shouldn't be necessary to have deep knowledge of other modules in order to understand the one that I'm reading, right? And finally, in approach, some code that you don't know, is it easy to find where to start, where to navigate from there, and so on. Extensibility and maintainability. We see modularity again here because, yes, for code, consider that it has to be modular and loosely coupled. Then minimum necessary dependencies. Again, modular and loosely coupled that a code is, the less dependencies it has, the easier it is to read it and understand it. And finally, useful abstractions. And by that, I mean that we know the different components and we design the interactions between them. And we use interfaces for that, also known as contracts. That's a very important one that we will be seeing today. Then verification, and obviously this is a big one, and I will concentrate a lot on tests today. Tests need to be exhaustive, meaningful, and specific. And I also like to do a pause here and give people a moment to think, why do we test, right? Probably the first answers that one usually gets to find and fix existing defects in the code, to avoid introducing new ones when someone if we have good set of tests, we are introducing defects. But then we can start more creative with tests, and we can start thinking about experimentation, right? Experimenting with our code. So for some scenarios that we didn't think about. For example, reproduce manual experiments. Sometimes we realize that we are doing some manual tests very frequently, and why not make that and put into a test? And also, why not to specify the desired behavior of our code, right? Tests define and specify very clearly what our code does or should do. And ideally, we should be able to communicate it in more or less unambiguous language, even so that maybe someone that is not a developer or not a very technical person can at least read the test and have a grasp of what the code should do. And also to discover interfaces, right? Because sometimes method, we need some properties, and then we go and add them, and then we write more tests and find out different things that we didn't know in advance that we needed. And if those two last things that I mentioned sound familiar to you, probably is because you heard of TDD, test-driven development. Obviously, I'm going to talk about that today. Yeah, behavior specification, I'd already mentioned. So now we're going to see this, how to develop high-quality code, particularly in Scala, what tools we have available. But I wanted to do a small pause and see if we have any questions. I don't see any in the comments, but please let me know if there are any.
No, Enrique, we don't have any questions as I see.
Yeah, okay. So tools and techniques, particular for Scala. This is not so particular of Scala, but we're going to see what we have in our ecosystem. And it's continuous integrations. And I cannot stress this enough, the importance of having a good continuous integration system. Continuous integration means the automation of integrating changes that are being made by different collaborators to the same project. And what we want to do is to automatically execute a set of verifications that will judge if change can be integrated or not. And I will encourage people to be very extreme with this, in the sense that try to automate absolutely everything. Everything that you can do automatically and don't have to do it manually saves you time, saves you from doing, human mistakes. And yes, for example, formatting the code, there are tools to do that automatically and to check that. We don't need to code review and take a look at what's the format. And I wrote this phrase, if it's not automated, it doesn't exist, because I've actually seen in practice cases where some person developed some very good test, for example, and it's not added to any continuous integration tool. And then because it's not enforced by some automated system, then the rest of the team doesn't use it, and then it gets out of date, and then in practice is as good as if it didn't exist to begin with. So, well, let's go now more deeper in Scala to automate the format I think the de facto standard, and I'm not aware of many alternatives. We have Scala FMT. It's very good. It works very well. Scala 2 and 3. And then we have linters. Those are, we can say that those are the ones that check I mentioned in the code style part, those kind of things. Well, first of all, the compiler. The compiler is our main linter. Just checking types is a linter step, we could say. There are even more configurations that we can do to the compiler to verify, for example, of unused variables, unused imports. And then there are other external third-party tools like ScalaFix, Scala Style. I think it was a great one, but I don't see active development. If someone knows about it, I would really like to use it, because I think it had some rules that I don't find in newer linters. Word Remover is a very good one, and it's also updated to work with Scala 3. And there is Scapegoat, another linter. It's only working for Scala 2, as far as I know. And yes, then testing. What tools do we have for testing? Well, I already mentioned test-driven development. It consists in writing the test first, and then writing some minimum implementation that makes the test pass. Then we go and improve the test, and that forces us to improve the implementation, and so on and so on. Coverage. Coverage consists in executing our test suite and measuring how much of our code was executed in our after our tests. And we measure the percentage of the total of the code. And then there are many options. We can set a minimum desired coverage. I am also here a bit radical here. I like to set 100% on the coverage, with the caveat that we can exclude files from measuring them. So if there's some file, some code that is absolutely impossible to test, or for some reason doesn't make sense to test, we can exclude it. And then it will be very explicit for other developers that that code isn't going to be considered in the coverage, isn't going to be covered by our tests, but the rest is completely tested. Mutation testing is another interesting tool that I think is underestimated. Basically, when we write tests, we test our code, but then you could think like, how do I know that my tests are correct? Or should I write tests for my tests? But there is when mutation test comes in useful. Mutation test consists in doing arbitrary changes to the code base and then executing our tests. And some tests should fail, because if we cover our code correctly, our code should do exactly what it's meant to do and nothing else. So any arbitrary change, for example, you can see that the tools for mutation testing change in a Boolean condition, they change an AND for an or they change less than to a greater than, or a filter for a filter not, etc., etc. And this is a very, very nice tool to find very otherwise hard to find bugs. And we will actually see one example today. And last but not least, property-based testing. This is the practice of writing generic properties about the behavior of our code and letting the framework generate the inputs for us. So let's imagine we have some function, and instead of manually setting some examples, let's say we're testing sum, and we write 1 + 1 should be equals to 2. We write the sum of the two integers should be greater than x, or whatever is the example was too simple, but whatever is your needs, you set some generic property about it, and then the framework will generate all the valid inputs, all the integers in that case that you will that you can imagine for the test. And it's also not so naive. It generates border cases. If it's integers, it will generate minus the minimum integer, the maximum integer, 0, obviously, everything in between. So yes, and I wrote there the Scala implementations. Well, TDD doesn't have a tool for that. It's just a way to develop. But for code coverage, there's coverage, mutation testing, Striker for S, and Scala check for property-based testing. Okay, enough talking. I'm going to show an example code. I don't see any questions, so I assume I'm clear to continue. Yeah. So for this presentation, I prepared an implementation of the game Minesweeper. I hope everyone knows it, or else I will feel very old. I will explain it very quickly anyway, just in case. The game consists of a board where all the, we will call them coordinates, start covered, right? Like the gray ones. And basically the goal is to step on all the, or uncover all the coordinates that don't have mines. And if we step on a mine, it explodes and we lose. If we step on a place where there's no mine, it will tell us how many mines are around. And we have this functionality to flag any coordinates. So if we know there is a mine here, for example, we flag it, and then if we click on it, we won't accidentally, explode the mine. It basically won't do nothing. Okay, so those are the rules of the game. And before going to the actual implementation, I also wanted to also think there are different slight variations of Minesweeper. This is the classic one, but there are, for example, other Minesweepers in 3 dimensions or hexadecimal, like the cells are hexa. And yeah, there could be variations of this, and just keep that in mind for the modularity aspect that we were going to discuss. Okay, so let me change to the IDE. I prepared this Git repository. It consists of 10 commits, and we're going to take a look to each of them one by one, starting in the very first one in the beginning, which is called just setup environment. right? So I just wanted to show you here that we can, before implementing anything, we can set up the modules that we know we will have. I set up some API and Square. I called Square the implementation. It will be the two-dimensional Minesweeper, but actually in a square. Like even rectangles won't be allowed for boards. And I already set my code coverage to 100%, as I mentioned, fail on the minimum, the word remover for the linter, some aliases to check the format of the code with Scala FMT. The linter basically is compiling. I only have word remover here because I'm using Scala 3, and it's basically the most useful right now, at least for me. And then test coverage, we just run the test and run coverage report from coverage. And utility verify that will do everything. And this is the GitHub Action configuration. We just say for any pull request or for any push to our main and check the test coverage. We're going to add testing later, and I didn't add it here because I want to show step by step, but in an actual real life scenario, ideally in the beginning. And I also want to show you quickly how to set in GitHub the configuration. It's slow. Our continuous integration will run as we configure there, and it won't allow us to merge any pull request if the continuous integration doesn't pass. So we require a pull request before merging. This is for main branch. And here is the basically make our pull request will only be mergeable once those CI steps all succeed. You can see here the history that you can see the commits hearing and seeing. Just guys checking because of slow. Matylda, maybe. Okay. Yes, I was showing here how the Scala FMT, very simple, just Scala 3 with the maximum columns and all the let's go. First commit is adding the game specification, right? Okay. Let's give it a minute. specification of tests. So we, as I said, right, basically the rules that I specified for the game. It should start covered when I set a flag. Cover an empty coordinate, uncovered. Should have a state, and it should start as playing. Where there is I shouldn't lose because the whole reason why it's like there. All right, then very basic specification. We should add the implementation of the test following our TDD approach. The test. So what I have here, the square which is the implementation. I have the squared spec will be an instance one with this factory, which basically tells how to create the board. Okay. And now you can take a look at this first implementation. What I did was really like the laziest possible solution, really the minimum that I could do to pass the test. And if you look at it, it's kind of funny or interesting because I have and returns a new board, right? A new instance. That for this new instance, if you ask the state of a coordinate, I will say it's uncovered. If you ask for the state of the game itself, it will say I won. Something similar for flagging, just with the states. I say that my implementation of all coordinates is just one, and has mine is false for everyone. All covered, and the state of the game is playing. There's something here that could be curious, and it's if you look at the tests, if you look at the specification, this specification looks this, and we see like these are all the rules. Even though these rules are there, just implement, right? And well, that's what I fix in the following to the board file to create a board. Because if you see the rules are true for this board, because in this board, whatever coordinate that you want will automatically uncover the whole board, and you will win, right? And then there are no mines in the board, so it's that if I any coordinate, so it's like okay for an empty. So in the next commit, when I'm going to test the factory, actually, the method to create new boards, is I'm going to say, well, you should create a board, but if I tell that, please give me a board that if I create a board, this parameter is the condition that we pass, which coordinates, which doesn't. I had to use this. We have here it could be rectangular, it could be three-dimensional, and we don't really care about it, right? So this test forced me to then go and so now to uncover one coordinate sort flag, keep it and the state of the game if we try to uncover that line, does it have a flag? If we uncovered a mine, then we lost, right? And here, just my code. You could, this is cheating, right? Or why care, right? Why do this? So this is not because we are super or because to have a miserable experience. Developer test. I said the when writing the test. Literature. Doing this kind of more tests and so on and so on. Keeping this mindset where we do the more tests, right? And there's also a twist to this. Work in pairs and write a test and one do the implementation, and it helps us create code with greater quality because it's better tested. It's forcing to keep independent states of the coordinates. That's because up until now I only the empty coordinates. I keep on playing, right? So here added that test, for example, uncovering some empty coordinates should keep the state as playing. And that forced me. Okay, so now, for example, the state of the board is 9, then this is the same, but if it doesn't, I check if I won, and coordinates that don't have mine should be pretty straightforward from the action. We keep this bond. Here I'm adding another test that verifies that actually this all coordinates and it was really only one or a line instead of square. And now I test that, well, there are, if I say size 9, there are 9, and they have X and Y, and there are those need to implement this rather ugly implementation of the because it has some conditions to meet to make it square, but that's all right. This is an example code. Okay, let's now go to mutation testing. We want mutation testing and see if that helps us find bugs. For that, I'm using Striker for us. The way to configure it is create this striker4s.conf file. I'm trying to set 100%, the same as with the coverage. That means that the test should kill all mutations. That's the jargon in the mutation testing. To be strictly less than low, so I had to set 99. That's a detail, but we create this file, we add the plugin to SPT, and with that we can add the one command, which is mutation test. I call it here, and there I just called Striker for my Square project. Striker is not working very nicely with multi-module projects. That's the reason why I'm doing this in the Square project. I obviously added to the CI. So I add that all the mutations should be killed before I'm able to merge a PR into the main branch. Okay. And well, I haven't showed you so far running the test, but we can do that. No. what I want you to see is, first of all, that, so you believe me that all the tests are working and passing. The coverage for the two modules is 100%. And here it says I created 18 mutations in the code. The 18 were detected and detected 0. That's a score of 100%. That's fine. I'll let you pass. That will allow me to merge the PR into main. The next thing here that I wanted to show you is this. Actually, when I was implementing projects, I found a bug with mutation testing. And here are the changes, and I'm going to revert this change. This is the fix. And we're going to run the test again. And we'll see why. What's the bug that I found. So first, see that all tests pass and code coverage is 100%. But there is at least there are two mutations that weren't detected by my tests. Striker shows you it was, in this case, it changed this for all to an exists. And here it's the same code snippet. It changed the filter to filter not, right? And it means that it changed filter to the opposite, which is filter not, and no test detected that. And that's probably a sign that something is wrong. And there is actually something wrong. If you see the fix, I was missing two things that were hiding each other. It's quite a you see in Scala 3 the identification, and it's done outside of this uncover, right? So it's defined at the class level. And so when I'm calling it here inside the method, I'm calling it on the previous state, right? And so the fix here is really or not. Yes, two tabs. Okay. And it was hidden also by some condition missing. The IDE. Never mind. The conclusion is this is a very hard to find bug, and even with 100% coverage, with all just passing, we did not detect this. And with our friend Striker for S, we can find even more bugs that we think. Do I have some more? Okay. Yeah. There we go. Yeah. Now I was missing one more change. Now with those changes, we get everything passing again, hopefully. Percent. Okay, that's enough of mutation testing. Let's go to property-based testing, my favorite one. In Scala, I think there are more libraries, but the most well-known one, I think, check. One of these, and I have a really the way to write tests with Scala check, find what they call generators in this gen class, and this will generate the inputs for us. And to do is properties of our code that I was mentioning during the for any board, really, I don't care. If I take well, it's covered, and we can do more. For example, coordinates. I can say for all board, then say for all coordinate in that board, right? I have a board and one coordinate in that board. I say, well, take the other coordinates, so all coordinates except this one, and assert that the state keeps the same before and after updating. The same for uncovering. And yeah, we have more features. For example, this double equals greater than this arrow is an implication. So what I'm saying here is for all board, if it has at least 2 empty coordinates, any empty coordinate, and I uncover it, the game should still be playing, right? Because if it has only one empty or non-empty coordinates, if I uncover anything, I either win or lose, but I don't keep playing. It's really, really interesting, really encouraging by composing and very familiar if you really used or more style structure, all the regular map, flat map, but also there are libraries to integrate. All you can imagine, you can do with the generators. In this case, it's simple because I want to have to generate some size, and the function that will set the mines, I give it some ability, and then I create some random function, and then just create a board. But yeah, and to use it because it not only gives you a much better looking test, more, right? Because test I had created tested properties with that, and it had like some set size and some function that with the hash code and even stuff. And here, if you see here, I completely removed that initialization, and I have truly random boards. Scala check will generate lots of them, and will test the property for all of them, small, big ones. It's really, really good for finding. It has the two benefits in one. Time, it helps you generate this separately, so it takes out it for test code. All right. Okay. Let's go to one more commit. Here, implement commands. What I wanted to show you here really is the that I mentioned before. And so this design from the beginning, where I and I have some particular implementation. Then I can also make the command client independent of the actual implementation. All I need is some factory to create my board and some way to parse the input. Interface, I just wrote some code to have a group that asks you first the size and the difficulty, and then you say uncover or flag and a coordinate, and it prints the state of the board, and you go on until you either win or lose. But here is how the command line interface only depends on the API, right? And then squared implementation, it depends on both. And we can see that the code for this is very small. It has the main, right, that says, oh, I have my command line interface with a square board and how to parse the square coordinates. This parser is really, really small. It's just the function where we parse. And with that, we have separated the interface from the implementation. We have separated the specs. We have reviewed usable specs, because as you see, this squared implementation the specs from the API will reuse the specs. The specs still have to be work correctly. And it's as modularity, as we were talking about it in the beginning. And yes, the last one is really just wanted to make it to when we a good what we call can go our code. Mostly other
Sorry, Enrique.
parse for the parse.
Enrique,
Yeah.
Sorry, I don't want to interrupt you, but we have comments that you are freezing from time to time. So I think that's because you are making some changes in this code and switching between different tabs. So maybe for a while you can turn off your camera. So maybe it will be better.
Sure. Yeah.
Thank you.
Let's hope that's better. Yeah, I saw the comments. I really don't know what to do in this case. I don't have code actually to show, so I will just run this just for demonstration purpose. So it asks the size. I will say 16 because it will be a square. Difficulty 0.1, and then it prints the 4x4 board. I say uncover 0, 0. There are no mines around. I covered 0, 1, 1, 0. I'm being lucky. 0, 2. Maybe the difficulty was too small. Oh, invalid inputs. Here you go. Well, I stepped over a mine there and I lost. So I wanted to here. The conclusions are we automated everything that was possible for us and determined a standard in quality. By a standard, I mean a bare minimum, right? Like I want to have a minimum from where to I will build. We build that helped us in debugging, and this made the process iterative and incremental. So yeah, thank you, and I will see if there are any questions.
Okay, thank you, Enrique. Do we have any questions? Maybe I will remove your presentation from the screen now. Oh.
Sure. I hope that the break. Have you tried vertical? Yeah. I'm not a fan of vertical alignment. I think by default, there is alignment in pattern matching, for example. So that's all I tried really because I set it like in the defaults, and I'm happy as long as the team has some standard to follow. Okay. I will I will try it.
Okay, guys, do you have any more questions to Enrique? Maybe I will leave Enrique's LinkedIn and email in case of any questions in the chat. So you can also contact him later in case of any questions. So yeah, okay. So I can't see anything more in the comments. So thank you, Enrique, very much for this presentation and for your time. I hope you guys that you enjoyed the meeting, and well, see you in the next functional world next year, in the new year.
Okay, thank you all, and I hope it was good enough to see the presentation. Probably some internet connection issues, but yeah, thank you for joining, and yeah, reach out to me if something wasn't very clear.
Thank you. Bye. Have a nice evening.
Bye-bye.